We were discussing about this, that is a scar, and we have done one example as well, right? That example was pretty easy, and that is why I have asked about another example, which actually is for non-integer multiples, like 6 hour precipitation, 6 hours duration of unit hydrograph was given in this example, and they have asked to find out the 3 hours unit hydrograph, and I have asked you to see this and go through this. And have you seen this example, new home? Have you gone through the example? This is a basic case where you can see that if the t is not an integer multiple of d, then what we actually do. The procedure will be same, but in this case 6 hour intervals were given, but we needed to find out what are the 3 hours intervals data, and that you can find out by interpolation or by this sort of graph. After plotting the graph, as because alternative 6 hours data were given, so you can plot the graph easily. After plotting the graph, you can find out what are the data for 3 hours interval. Those are not actually given, so either you can do the interpolation or you can draw the graph, and then you can find out what are the values uh, of coordinates in 3 hours intervals, right? So they have plotted the graph, and they find it out these sort of values which are marked as red were not given. The red mark data were not given. The blue mark data were given, right? So the basic funda is same. After finding out those things, the procedure will be same, right? So you have to find out the 6 hours A star first of all. One A star you need to first of all find out. Then you have to find out another A star that will be lagged by T hours, where T is the time period or time duration for which you are trying to find out the unit hydrograph. So this will be lagged by 3 hours, right? So S1 and S2 will be lagged by 3 hours. So after 3 hours, it will start from zero, and all the data will be same. It will just lag by 3 hours. Then you need to find out the subtracted value, subtraction of S2 from S1. So you can get those values, S1 minus S2. You can simply subtract the ordinates. Then obviously after a certain time, both the values will be same, that is why all the values will be zero, so we'll get a ordinates for 3 hour unit hydrograph. But what you need to do after subtraction, you have to multiply the value of d by t. D by t, in our case d is what? D is 6, right? P is what? T is equals to, d is equals to 6, t is equals to 12. 12. We are finding out the unit hydrograph of 12. We are finding out the unit hydrograph for the 3 hours. So T is 3 in our case, right? So you need to multiply D by 3. That means this column will be multiplied by 2. 6 by 3. That is 2, right? In the other case, we have divided the value with 2. Why? As because D value was 6 and T was 12, right? In the previous case, D was equals to 6 and T was equals to 12. That's because this was given, these ordinates were given, and we are trying to find out this one, right? That is the unit hydrograph for 12-hour duration of precipitation. In this case, opposite one is happening. That is D is 6, but T is 3, right? So in this case, you have to multiply D by T, and that will be equals to 2. So that is why in this case, we are multiplying this column with the 2 value, right? Thick. So that was an example where the T was not an integer multiple of D. T was not an integer multiple. That was a fractional multiple of D, right? 0.5 of D. T was equals to 0.5 of D. So for those cases where the fraction multipliers are there, what we can do? Procedure will be same, right? We can follow the same procedure, finding out the S curve, S1 and S2, then we can easily find out what will be the unit hydrograph for the different division. Clear? That was up to the hydrograph part, where we have learned about the hydrograph, various hydrograph, flat hydrographs and all, and we have learned about the unit hydrograph, as because to find out all the hydrographs for each and every storm is very difficult, right? How we can find out the hydrograph? Measuring the stream flow, right? Measuring the stream flow, we can find out the hydrograph. Okay? So for each and every storm, it is difficult to find out hydrograph. That is why what we do, we generally plot one unit hydrograph. That is, you can say a fixed hydrograph for a catchment area, right? And we multiply the excess precipitation, excess rainfall with that ordinates, and we get the flood hydrograph. Okay? And doing so, some constraints were there. That is, duration will be fixed. That is, dr duration unit hydrograph can be used only in dr duration of precipitation. So to overcome that one, we needed to do something. That is why we have done these two methods. That is, method of superposition and S-curve method. So that one dr unit hydrograph is given, but suppose your precipitation is not in drs, it is in trs. Then how we can find out the unit hydrograph, and then how we can find out the hydrograph? Clear? The idea is clear enough. So that is about the hydrograph, and now we will discuss about the next chapter, and actually not the next chapter, this is the previous chapter of this one, but this has no interlinks. That is why I have done this thing, and next we will go to the previous chapter, and that is actually from where we will find out the hydrograph, right? Now just a few minutes before, I've said that we can find out the hydrograph measuring the stream flow, right? When you measure the stream flow, that means you are measuring the discharges, and obviously in hydrograph, discharge versus time, that is the requirement. So you need to find out the discharges. To find out the discharges, you need to measure the stream flow, right? So how we can measure the stream flow and all, that is all about this is a graph for the previous one, right? How we can find out or how we can measure the stream flow, that is our next case. Now we all know what stream is, right? We all know what stream is. Yes or not? Yes. What do you understand about the stream? Yes, एकदम. Yes, correct. Correct. So basically, open channel through which all the excess water flows. An open channel through which all the excess water, that is the direct runoff, flows, right? So in majority of the cases, we see the river as a stream, right? That's because that is the main outlet of a catchment area, and obviously you need to. I've already told you that on a catchment area we have to study all the water incoming and outgoing, right? So incoming water you are getting from the various gauges, right? Losses you can find out by various methods. In the losses chapter, we have learned about the evaporimeter and infiltrometer on all the things, right? Through which we can study what are the losses. But what is the outflow? What is the outflow? Outflow from a catchment area will be one, and that is obviously will be the stream one, right? Through the stream it will flow. So that is why we need to study this one, or we need to study the stream flow. So basically, a stream is defined as an open channel that carries the surface runoff from a catchment. Clear? The definition is clear, simple. The discharge it carries is the stream flow. That means the discharge amount of water will be called as stream flow. The channel will be called the stream, and the flow will be called stream flow. In fact, stream flow is the output or response of the catchment due to a precipitation over it, right? So basically, stream flow is the response of a precipitation in a particular catchment area. Here, obviously, that will be the response. Now we are coming into the stream flow measurement. Why we need to measure the stream flow and how we can measure the stream flow. So basically, they are saying in surface water hydrology, the most important task is to estimate the amount of water available. Right? We have all discussed those things in previous introductory part of engineering hydrology. That why we need to study the amount of water, why we need to study all the things, right? So this is one important thing to find out what is the amount of water we can get after one precipitation, right? After one precipitation, what is the amount of water is available to us, available in the catchment area, particular catchment area. That is why we need to study this one. Runoff from a catchment due to a storm can be estimated approximately if information about the losses parameters like evaporation, infiltration, etc. are available. So in losses chapter, we have seen the same thing. We have seen the same thing. That is, if all the losses are known, we can know the runoff, right? If all the losses are known, we can find out the runoff, or vice versa. If we know the runoff, we can find out the losses. Now, evaporation can be found out, right? Evaporimeter. Infiltration can be found out, infiltrometer and other things. But in the losses chapter, we have already seen that to measure various sort of losses is pretty hectic. Yes or no? Measure it accurately. Measure it accurately is pretty hectic. You cannot find out the exact value of the evaporation, exact value of infiltration and all. Obviously, you cannot find out the stream flow as well. That will not be exact, but that will be more accurate, right? With respect to the losses, right? So if we find out the stream flow, if we know the stream flow or if we measure the stream flow, that will be better, right? So, however, precise measurement of these parameters are difficult and the adopted methods are having their own limitations. We have already seen those things. Huh? Also, it is very difficult to estimate the variation of surface runoff with time, right? In contrast with this, direct measurement of the stream flow is relatively easier. Finding out the stream flow in a channel, in a river is much more easier than the previous one, right? So what are the techniques available to us? The techniques are direct determination method and indirect determination method. We can find out it directly or we can find out it indirectly. In direct method, we are having area velocity method, dilution technique, electromagnetic method, ultrasonic method. And in indirect method, slope area method is there and hydraulic structure method is there. We can find out or we will see those methods obviously in details in future classes. We will see all the details. But those are the techniques available to us. Mainly two, that is direct and indirect. In direct sort of methods, we are having four type of method: area velocity, dilution, electromagnetic, and ultrasonic. and in indirect slope area and hydraulic structure. Those are the methods available to us, right? Now we will talk about another thing that is called the stage velocity discharge. Stage velocity and discharge. Velocity we know, right? Discharge we know. We have already studied in those fluid mechanics and all. The only thing is pretty unknown is that stage one, right? Let us see what is stage. Basically, we are trying to find out the relation between those three things. That is stage, velocity, and the discharge. Actually, we cannot, we will not find out actually the total amount of discharges in streams. We will find out it indirectly, and we will follow this sort of steps. Three steps are there. So basically, continuous measurement of stream discharge is very difficult, right? So suppose you are having the Damodar river over there, right? Damodar river, and obviously each and if you want to, you are having some sort of river or something, right? Nearest to your home, you are having some sort of stream, and that is pretty difficult to find out what is the amount of water actually passing by the stream all the time. Yes or no? It is pretty hectic. So basically, this is very difficult and time consuming and obviously costly. Hence, we are having these three sorts of steps by which we can find out all the velocities or what are the discharges in streams according to these steps. First step is a series of careful measurement of discharge and corresponding water surface elevation are performed for the stream, right? So various series we will find out. Various series of what? Series of measurement of discharges and corresponding water surface elevation, right? So we are having one, suppose cross sectional area of river, and this is the elevation of or level of water, and for this particular level of water you will be having some sort of volume of water, right? And that volume of water will have some sort of velocity. So basically you will get some volume of water per unit time. That is actually what discharge is, right? Volume of water per unit time. So basically you are having volume and velocity, right? That volume is having two things, that is the length actually crossing per unit time, and what is the cross sectional area. Now that cross sectional area we can see over there is dependent on the elevation, on the height of the water, and obviously the height of the water will not be same in each and every time. That is the main, you can see, or you can say that is the main variable in stream flow. In a particular river, in a particular times, velocity obviously it will differ, right? But the main difference, it will the volume discharge will be created, that is the level. Bolo. Cross sectional area of the water, right? Cross sectional area of the water, right? Area multiplied by the length. Length is what? Length crossing by the river per unit time. So basically, you can see that discharge will be dependent on the value of the surface elevation. This is clear, right? The discharge indirectly, directly, obviously directly, but some other elements are there for which the discharge will be dependent, on which the discharge will be dependent. But the main dependency will be the elevation, as because if elevation changes, cross sectional area will change, volume will be changed, volume will change, so discharge will change. So we can find out some relation between this discharge and elevation in various time and various series we can perform. This elevation, surface elevation, will be called as stage. Now this is one sort of stage, suppose. In another stage, suppose different color we are having, yes, different color. In a different stage, we are having a different elevation. So this is different stage. Elevation changes, stage will be changed. So basically, in this case or in this context, stage is being referred for this elevation, nothing else. Clear? Now that elevation will be dependent on some, obviously you will have some sort of datum line through which or from which you are trying to find out the elevation. Some datum line will be there. Okay. Now this is clear. We are finding out the relation between those two things. Secondly, what we will do, obviously all time we will not find out the discharges. Secondly, what we will do, stage discharge relationship is obtained for the measured set of data. So we are finding out the what is the relation. We are selecting some sort of set of data. We are finding out the relation between the stage and the discharge. Next, what we will do, from the next time onwards, only the stage is measured routinely. We will find out, or we will get the stage, and according to the stage we can find out what is the discharge. As because stage discharge relationship we are creating, stage discharge relationship we are creating, from the next time onwards we will only find out what is the stage, and from the plot or from the relation we can see what will be the discharge against the stage. Clear? Clear now? Okay. Now usually this step one, this one, discharge is not measured directly. So whenever we are trying to find out the set of data for stage, that is the elevation, and discharge, discharge cannot be find out directly, right? যেরকম করে আমি বোঝালাম, the like the way I like just shown you, we cannot find out the discharge directly, or that will be pretty hectic. So what we can do, that is, discharge is not measured directly. Instead of that, stream velocity is measured. Velocity is measured and discharge is obtained by multiplying the flow area. Right? Discharge Q will be equals to area, that is volume per unit time, right? Volume per unit time, that can be referred as T, right? Volume, we can find out area multiplied by some sort of length per unit time, right? So we are not finding out the discharge directly. Instead of that, what we are finding out, we are finding out the velocity, first of all, velocity, and the area, cross sectional area. এটা একটু ভুল আছে, VA, right? VA, velocity into area, তাই তো? Velocity into area. So we are finding out the velocity, and next we are finding out the area, where the area can be dependent. Obviously, area will be dependent on the elevation itself, right? So area will be dependent on the stage again. Clear? Any confusion? Any confusion? Huh? Clear. Now, basically, we have to find out all the things, that is stage, velocity, and cross-sectional area. Stage, velocity, and cross-sectional area. So first of all, let us try to find out the stage. So first of all, we are having measurement of stage. How we can find out the stages? That is the elevation, nothing else. So what is stage? The stage of a stream is defined as the elevation of the water surface measured above a datum. What I was talking about, that is, you have to find out the elevation of the stream from some sort of datum, right? Now that datum level can be the mean sea level or anything else, right? Thick. So basically, suppose you are having some sort of stream. This is the ground level. This is the stream flow, and this is the datum line. So we can find out the elevation, right? Now to find out that one, we are having this sort of recorder, that is manual recorder is there and automatic recorder, stage recorder is there. In manual stage recorder, we are having two type of gauges, that is staff gauge and wear gauge. And in automatic stage recorder, we are having floating sort of gauge and bubble gauge. Four type of gauges are there. Let us see about all the gauges. First of all, we are having the staff gauge. I think most of you have seen this sort of stage recorder. Most of you have seen. Bolo? Canal, right? Any sort of canal you will get this one. Any sort of near the barrages you can get this sort of stages where mark will be done. Various marks will be done. Graduated scale will be there, and obviously water level will be connected to the stream directly, and water level will be equal to the water level of the stream, right? So from there you can directly find out this one, but you have to go there and see and note it down. But that is why it is manual, right? You have to record it, you have to write the all the data, right? So this is the simplest one. One graduated scale will be there, or graduated staff will be there. We have already seen the staffs in surveying, right? In surveying, we have seen the staff now. In leveling, we have already seen those things. So that is the same thing. That is why it is called staff gauge. One sort of staff will be created that will be fixed. That will be fixed. One pillar type or pier type of structure. Now these are there are three type of graduated scale can be used, that is vertical, that can be inclined, and that can be sectional. So vertical, mainly all of you have seen this sort of thing, that is a vertical one. Inclined one is like this one, which will be inclined with the bed of the river, right? That will be a bank of the river, that will be inclined through the bank of the river, and this will be there will be some sort of graduation, and that will be inclined. That is why it is inclined, and this is sectional. In various sections, we can get some sort of piers again. Obviously, the verticals one, but we are not having only one pier. Instead of that, we are having different sort of sections in various depth. In various depth, various piers are used, right? So there are three type of staff gauges are there. Secondly, in manual recorder, we are having the wear gauge. In this case, what they are doing, that wear gauge is used to measure the water surface elevation from a structure above water. Suppose this is the structure, water structure, right? Any sort of structure is there, and you can install it over there, and then you can use it. How? In this, a weight is lowered. So at the end of this wear, this is one sort of wear. That is what it is, wear gauge, right? This is one sort of wear, and at the end of the wear, some weight will be provided, and this weight will be lowered by a reel to touch the water surface until and unless it touches the end of the water or the bed of the river. right? Mechanical counter measurements will be there, and that will be rotating obviously with respect to the reel whenever you are flowing down the reel, and that will which is proportional to the length of the wear paid out, right? So that rotation with respect to the where you can count the rotation, with respect to the count you can find out the what is the amount of the length of the where actually inserted inside the bed or the elevation of the water, right? So that is how you can measure the depth of the river water here, right? So basically you will install this sort of box you will install over some sort of structure, right? Any sort of bridge, barrages or something you can install it, and then you have to lower it, and you need to count the rotation, and with respect to the rotation obviously you will get the length of the wear here na. Simplest one. Those are the simplest one was the last one, but the graduated scale will be there directly. Now, those are the manual type. Next, we are having the mechanical type of gauges. First of all, we are having the float gauges. So, in this case, one whale will be there. That is called stealing whale, right? Whale-like structure will be there, and this is the walkway through which you can control or you can access the inside of the whale, and you can do all the things, right? And inside the whale one float will be provided, right? So basically this is the level of the water, of the river, right? This is the whale constructed inside the river, and obviously you will have some sort of walkway. Why? As because it cannot be constructed at the end of the river. You need to make it clear that this end of the whale should touch the end of the river or the bed of the river, right? So that is why you need to get the depth, right? After that, what one float is provided, obviously that will be floating over the water level. Then this float is basically connected with one wire, which will be crossed over one pulley, right? And at the end, another end of that wire, some sort of counter weight will be provided, right? Counter weight too, as because obviously the level will be rising or falling. So with respect to that, if it is suppose rising, so suppose this level or elevation water level is rising, then what will happen? This float will be rising with the, then what will happen? This will be shortened up, right? That is why one counter balance or counter weight is provided so that the pulley can be rotated. Why the pulley's rotation is so important? As because with respect to the rotation of the pulley, समझ आ रहा है ना? So basically we are having pulley, in this side we are having some sort of counterbalance load, and in this case we are having the float, right? So with the rise of the float and the fall of the float, what will happen? With the help of this weight, this whole thing will be rising or falling. So with respect to that, this pulley will have some sort of rotation, either in this direction or in this direction. So in this pulley we are having some sort of angular movement. In this pulley we are having some sort of angular movement. Now that angular movement can be stored by signal system or mechanically, by electronics gadget or mechanically. This rotation or angular rotation of the pulley can be stored, and with respect to the angular movement we can say what is the elevation loss or rise, right, of the water level. So basically the float gauge is the most common type of automatic stage recorder. In this, a float is operating in a steering wheel by means of a counterweight over the pulley, right? displacement of the float due to the rising, जो मैंने the drawing I have already told you over there, with respect to the rise and fall of that float, what will happen? uh, Displacement of the float due to the rising or lowering of the water surface elevation causes an angular displacement of the pulley, right? This angular displacement is converted into the vertical movement by a mechanical clockwork. A digital converter is also sometimes used. So either mechanically or by electronics method, we can convert that rotational movement or angular movement of the pulley in the horizontal or vertical movement. Vertical movement means vertical movement or displacement means the rise in elevation or fall in elevation. Simple, right? So we can measure by mechanically or electronically. We can find out the rise or fall of the elevation. Clear? Okay. हाँ बोलो बोलছো কিছু Next, we are having this sort of thing that is called bubble gauge, right? That was automatic, right? The last one, it was actually recording automatically. Yes or not? So manual, two type of manual I have seen, one type of automatic recorder we have seen. This is the second one that is called the bubble gauge, and in this, what actually happens that gas or air bubble is provided over there at the bottom of the river, right? And some sort of pressure point, pressure measurement instruments are there. So you need to measure the pressure of the bubble, and that bubble pressure and the pressure exerted by the water, right? That will be equal. The bubble pressure over there and the pressure exerted by this amount or this height of water column, we can consider one water column over there. So that water column, by its weight, it will provide, or that pressure will be equal, and we can measure and control the pressure of the bubble. If there are any changes in the bubble, that means what? If there are any changes in pressure at the bubble, that means the pressure exerted by water is changing, right? And when it will change? It will change only when the elevation is higher or lower. Maybe elevation is rising, so obviously pressure will rise. If elevation is falling, then pressure will drop, right? Now if there are any changes in the water column, that will be affecting the pressure at the bubble, and we can see or measure the pressure over there, and by converting the pressure with respect to the height of the water column, we can get the difference in the elevation. Clear? Right. Let's see. In this gauge, compressed air or gas is made to bleed out or at the very small rate. In very small rate, we will bleed some sort of bubbles at the bottom of the river, right? A pressure gauge measured the gas pressure, which in turn is equal to the water column above the outlet. So basically what we are finding out? We are finding out the pressure of the gas, right? Gas pressure. Pressure of the gas or gas pressure. So by this pressure gauge, we are finding out the gas pressure mainly. and that gas pressure will be equal to the pressure exerted by the water column, right? Clear? Now, what will happen? A small change in the water surface elevation, a small change in the water surface elevation, suppose it is falling, the elevation is falling or rising. Obviously, this column over there, this column, the weight of the column will be increased or decreased. If the weight of the column is increasing, that means pressure exerted by the water will be increasing. If decreasing, then the pressure will be decreasing. Right? So a small change in the water surface elevation is felt as a change in pressure from the present value at the pressure gauge, right? So basically, any sort of change is there, the pressure gauge will feel the same change. The pressure gauge provided at the bottom, that will feel the same sort of changes in pressure, and this in turn is adjusted by a servo mechanism to bring the gas bleed at the original rate. So to bleed the air bubble at the original rate जो पहले था, right, at the previous rate, obviously it will adjust some sort of the adjustment to give it the same blow or same sort of pressure, right? The pressure gauge reads the new water depth, which is transmitted to the recorder. Now this pressure gauge, from this pressure gauge, some signals you can send, and you can record the signals of the pressure, and obviously you can find out what is the change in depth or elevation, right? It is also automated. What are the positive side of pros of this sort of bubble gauges? That the bubble gauge setup cost much less, right? वहाँ पे we have seen some sort of well is constructed. Obviously, the construction is pretty much higher. In the last case, float type of gauges. So this, हाँ, that thing was there, na? The same mechanism was there, but that is manual, right? The easiest one, the initial one, that is the graduated stuff. You need not any sort of tape or anything else, right? That is the easiest one, but those will be manual. You need to go there, you need to record all the things. Why you are recording this one? To find out the discharge only. Otherwise, what will happen if we try to find out the discharges? We will go to the stream, and like you say, we will lower some sort of some type of tape. At the end, we will fix some sort of weight, and we will lower it down, and we will measure the length or elevation, right? But this is on the time we are trying to find out the discharges. But this is not only done to measure the depth or measure the discharge. We will find some sort of graph with respect to that, with respect to time. So in intermediate of time, we need to find out what is the depth. Right. Manually you can do. That procedure is also there, right? The bubble gauge setup costs much less than the float gauges, and the recorder assembly can be installed far away. So that recorder assembly for this case, you can install it far away from any sort of interruption or something, right? And there is another thing, that is chance of blocking is pretty lesser than the previous one, as because various element will float on the river, at the top of the river, right? And that can affect the float type of gauges, right? It can be stuck at the float, and obviously it will affect the measurement. So in this sort of case, the blockage is the fear of blocking is pretty less, right? And why we are doing this one, তুমি দেখো একটু, ওই তুমি জিজ্ঞেস করেছিলে না, আমি বললাম একটু আগে যে we are not finding out the elevation to find out the discharge only. Why we are finding out this elevation? We are finding out this elevation to create this sort of graph, graphy graph. In water resource, you will get graph and graph and graph, data, storage, and you need to study all the data. Right now, in the example, you will write down heatograph instead of hydrograph. Someone says hygrograph. In the previous CA3, someone written hygrograph as a instead of hydrograph. Many of you have written heatograph and all. Right. Okay. Now we are finding out this one to find out this sort of graph, which actually includes stage versus time. Stage versus time. Stage is what? Stage is nothing but the elevation, right? So various elevation with respect to time, nothing else. So we will draw various stage or various elevation with respect to time, and this sort of graph will be called the stage hydrograph. Stage hydrograph. Right? Stage hydrograph. So the stage data is usually presented in the form of a plot of stage against chronological time. This plot, known as stage hydrograph, is very important. See, this one is very important in flood warning, flood protection works. Right? So we are not only finding out the elevation to measure the discharges. We are studying the discharges to study the flood as well. So that we can get the idea of flood, we can warn someone or people for the floods, or we can control the flood as well. Right? It is also useful in design of hydraulic structure like bridge and weirs and all. Right? So it is useful for that study as well. Now this is the study of the stages. Next we will try to find out or measure the velocity, and देखा जाएगा उसके बाद how we can find out the discharges. Finally aim is to find out the discharge, right? Stream flow. Okay, thank you. Any question by the way? Hey?